All right, I'm going to continue right where I left off in the last video, except right now, instead of talking about angles on our unit circle, we're going to talk about angles that are no longer on our unit circle. With that being said, right here, if you know that the sine, cosine, or tangent ratio of an angle, and you don't know what those values are, you don't recognize them from the unit circle, what you can do instead is use inverse ratios here. So, for example, right here, if you have sine inverse of x, you can find the angle. In other words, normally you would input the angle sine of some angle and you would get some output value. Instead, you're going to swap them. So same thing here. Arc cosine of x is going to get you the angle measure, or arc tangent inverse of x will get you the angle measure. So we're going to use that information down here in order to solve some of these. So right here it says use step number 1, use sine inverse, cosine inverse, or tangent inverse to find the reference angles. So what we're going to do right here is I'm looking right here at tangent theta is 8/14. So I'm going to write this as an inverse relation. So I'm going to say this is tangent inverse of 8/14, and that's going to get me my angle. So what I need to do at that point in time is I just need to be able to put that into my calculator. So before I go to put this in the calculator, I need to make sure that it's in the correct mode, because what I'm going to be working with is going to have output values of degrees, and I'm using trig functions. I want to hit the mode button up here next to second right here, hit that mode button, and then I want to scroll down to radians, and I want to select degrees. I want my information to be in degrees, and then I'm going to hit second mode so I can get back out of that screen. You can also see up here it says degrees up here, so that's kind of just make sure that I'm in the correct mode to do this. And so now I'm going to do second tangent because that gets me that inverse tangent function, and then I'm going to do 8/14. And when I do that, it gets me an output of 29.7. So we're going to use that, 29.7 degrees. Well, there we go. So theta is going to equal 29.7 degrees. Now, that isn't necessarily all I want to have. So let's think about this. So tangent is positive in quadrants 1 and quadrant 3. Okay? So if you notice right here, I have tangent of theta is equal to that. And this isn't tangent inverse. So I'm not restricted to just having quadrant 4 and quadrant 1 as my only answers. That's only if I'm given something where it's tangent inverse. Notice that's exactly what I did here. I did tangent inverse of that. It gets me a number, and notice that's going to correspond with the number that I have right there for 29.7 degrees. It's a positive acute angle measure. That is my reference angle that I have right there. So that is where I have my angle for quadrant 1. Now what we're going to be doing here is we are finding all angles. I'm going to change these directions a little bit. Instead of find the angle in degrees, we are going to find all angles. So let's change this. Oh, not the all. Find all angles in degrees given the information. So that's finding every single angle that I need to have. We're not going to assume they're all in the first quadrant because that is not at all what we are doing here. So I have 29.7 degrees. That corresponds with this angle measure that I have right there. Do we or do we not agree that if I add 360 degrees, I would be right back right here? I would, correct. Okay, if I added another 360 degrees, I'd be right back there, wouldn't I? So what we're doing here is I'm going to say I've got that 29.7 degrees plus 360 degrees K, where K is going to represent some integer input to represent how many times do I circle around. Was it 1 time, 2 times? Was it 46 times? Was it negative 22 times? How many times have I gone around this circle in a full 360 degrees? That's it. That's all it represents. Okay. So now what do I do at that 29.7? Because somehow or another, I also have to find this other angle measure that I have over here in the third quadrant. Well, it says right here, step number 2 was to identify the quadrants in which the sign of the sine, cosine, or tangent can be what it is given. Well, that's what we did. That's first and third. Okay, now apply proper rules based on the quadrant. So how am I going to find this blue angle in the third quadrant? Well, do we agree that the 29.7 degrees was how far above the x-axis this one was right here? That represented this angle measure? Yeah, that was our reference angle, wasn't it? Well, if I'm in my third quadrant, I can find my angle measure by doing 180 degrees. So I'm going to call this theta 2. And we would do 180 degrees plus our reference angle, which was that 29.7 degrees. And so when I do that, I get an angle measure of 209.7 degrees. And that corresponds with this angle measure here in the third quadrant. But again, I need to get all angles. So I could just take that and I could add 360 degrees with some integer k. And that gets me all possible answers that I could have for theta there in degree measures. Okay, let's try number 14. So if I go right here, cosine is negative. So again, I don't care about the number right now. All I'm looking at is it's negative. So let's think, where is cosine possible to be negative? Cosine represents my horizontal. So that's going to be over here or over here. Okay, so quadrants 2, quadrant 3, that's where I'm going to have a negative cosine value. And if I turn this into an inverse cosine, so cosine inverse of negative 38 over 40, that'll get me the angle measure of a cosine in my second quadrant. Well, sure enough, the angle measure in my second quadrant would be this angle measure right here. So it's going to get me all of that. So if I take my calculator and I put that in, so let's go ahead. Well, we'll put that in, cosine inverse, and it's negative 38 over 40. Okay, it gets me 161.8. So let's go back over here, 161.8. That's going to correspond with this green angle measure right here, 161.8 degrees. So let's go ahead and consider what that is. So that's going to be this whole angle. So we're going to go theta is equal to 161.8 degrees. And then we can get every possible answer because again, if I add 360, I'm right back. Another 360, I'm right back there. So plus 360 degrees K. That gets me every possible answer for my angle measure that will land right here on this terminal side right there. Okay, now I got to find the other one. So the next step here is I've got to go ahead and find the rules to find the angle measure there. Well, let's think. I got to find my reference angle. So the reference angle is going to be the acute angle measure positive above the x-axis between the terminal side and the x-axis. So to find this little acute measure that I have right there, I'm going to have to say, okay, so let's find our reference angle. That's going to be 180 degrees minus 161.8 degrees. And when I do that, that gets me 18.2 degrees. So that's what my reference angle is. That's that little angle, a measure above the x-axis to the terminal side. It also is this little angle measure below the x-axis to the terminal side. The reference angle is the distance from the x-axis to the terminal side of my angle. So if I go ahead and look at that, if I could call this theta 2, so let's do that, theta 2, then I'm going to go, okay, so that's 180 degrees plus 18.2 degrees. So that is a total of 198.2 degrees. And that's what we get when we go from the positive x-axis counterclockwise all the way around to where this terminal side would be for my angle measure there. So that's 198.2 degrees plus 360 degrees K to get all possible solutions. So my all possible solutions would be this answer as well as this answer here. Okay, let's try this one right here. All right, so let's think about this one, sine. All right, well, where is sine going to be negative? because that's what I'm looking at here. I don't care about the numbers. I care that it is negative. Sine is my y variable or coordinate. And so that's going to be negative down here in quadrant 3 and quadrant 4. Okay, so when I do inverse sine, it's going to get me the one over here in quadrant 4. It's going to get me this one. And so I'm going to have to do some math to figure out what the other one is. Okay, so let's go ahead and do that. So if I go ahead and do sine inverse of negative 17 over 22, I'm going to take my calculator, put that in. Sine inverse of negative 17 over 22. Negative 50.599. Okay, negative. Why am I getting a negative angle measure? So let's think about that. What that negative angle measure here is exactly what I kind of said it was. You know what? Let me kind of change this a little bit. Give a little bit of space here. There. That negative angle measure is what I have right here. Remember, a negative angle measure is when I'm going from the positive x-axis as my initial point, and I go clockwise. Well, sure enough, isn't that exactly what I'm doing right here in green? If I'm going from this positive x-axis to this terminal side that's over here in the fourth quadrant, I'm going down, and that's getting me a negative angle measure. And so that's exactly what I should be getting here at this is negative 50.6 degrees. And that's perfectly fine. I can just use that angle measure as what I have right here. I have negative 50.6 degrees plus 360 degrees K. If I was to take that same exact negative 50.6, and if I go counterclockwise 360 degrees, it gets me right back another 360. So you see, it's going to do the same thing. So that's one of them. Now we got to find the other one, and the other one seems to be a little bit more challenging for people if they don't really understand what a reference angle is. So again, let's reiterate. A reference angle is a positive acute angle that measures the distance from the x-axis to the terminal side of my angle. So in other words, I'm going to be looking for the acute angle from the x-axis to the terminal side. Well, it's also the acute angle that matches this one right here, because these are going to be exactly the same, okay? So if I go down 50.6, I'm also going to go down 50.6 there. My reference angle here, if you really want to do all of the hard work, negative 50.6. We got to get a positive coterminal angle. So I'm going to go ahead and add 360 degrees there. And that gets me 309.4 degrees. That 309.4 degrees is going to represent the whole entire angle that I have right there. I don't need to do this. Again, I'm reiterating, I don't need to, but some of you need to because you don't understand what you're doing. So this 309.4 degrees is that whole angle. Well, what is the reference angle of an angle measure of 309.4? Remember, if it's in the fourth quadrant, we go 360 degrees minus the angle measure, so 309.4 degrees. Well, that's going to come back and go 50.6 degrees. So like I said, the negative angle measure is the reference angle. You just make it positive because it is the distance from the x-axis to the terminal side. So instead of going above 50.6, we went below 50.6 right here. And so it's the same thing. It just has directionality to it. So really now, in order to find the full angle measure, and let me kind of clarify because I got a couple different colors over here. What I need to find is the angle measure of this whole entire thing. So what we found is the 50.6 is the acute angle from the x-axis to the red side right there. So I just need to add 180 to it. So I would do 50.6 degrees plus 180 degrees. And that gets me 230.6 degrees. So that corresponds with this whole entire blue angle. If I go from this initial side right here, positive x-axis counterclockwise all the way around to where this is, it would be 230.6 degrees. So our final answer here would be 230.6 degrees plus 360 degrees. Okay. So that corresponds one answer here and one answer here. Okay, Hopefully that makes some sense to you.